All right, so we'll get started here with the webinar. So good morning or good afternoon, depending on where you're joining us from today. Welcome to our exclusive webinar on simulation workbench on Windows. I'm Justin Moore, digital marketer here, and I'll be your host for today's session. And we're just really excited to have you here with us as we dive deep into one of our new and exciting products. Today, our Vice President of Product Management, Dr. Anish Anthony, will be going through our new product, Simulation Workbench on Windows. Anish brings a lot of knowledge, experience in real-time technology, and we're looking forward to getting some insights from his expertise. Today's session has 3 key objectives. First, Anish will break down what real-time technology means and what and why it matters. Next, we'll introduce you to our Simulation Workbench, highlighting its key features and benefits. Finally, we'll explore the exciting integration of Simulation Workbench on Windows, showcasing how this evolution will bolster your solutions. Please feel free to send in your questions at any time during the presentation. We'll have a dedicated Q&A segment at the end where Anish will answer as many of your questions as he can. And without further ado, I'll hand it over to Anish. Anish, the floor is yours.
Okay. Hello, everyone. Good to see a good number of people join the webinar. I'm super excited to present this webinar as we add a new capability into our portfolio of products. And so I'm going to turn off my camera so we focus on the presentation and not on myself. But feel free to ask questions into the Q&A so we can address as many of them as possible towards the end of the presentation. So today, this is the agenda for our webinar today. Today, we are diving deep into the realm of simulation, modeling, and testing, exploring how they serve as integral components of the model-based design process. We will start by looking at the real-time spectrum and talk about how leveraging Simulation Workbench framework, particularly on the Windows platforms, can serve as a catalyst in accelerating our testing processes. We will end with a demo on the whole process on how to get Sim Workbench server installed on the Windows side and testing it with a Simulink model workflow. So let's talk about the real-time spectrum, which includes different levels of responsiveness in computing systems. At one end, we have non-real-time systems. On the left side, as you see, these systems might handle tasks where timing is flexible and delays are acceptable without causing significant issues. Moving along the spectrum, we encounter soft real-time systems. In these systems, timely response is important, but occasional delays can be tolerated without catastrophic consequences. Examples include multimedia streaming and online gaming, where missing a deadline occasionally might lead to reduced quality, but doesn't result in system failure. Finally, at the right end of the spectrum, we find hard real-time systems. Okay, so these systems have stringent timing requirements where missing a deadline, even by a fraction of a second, could lead to system failure or even endanger lives. Examples include air traffic control system, rocket missile launch control systems, nuclear reactor controls, automotive safety systems, etc., where timing is absolutely critical for proper operation and safety. Understanding the spectrum is crucial when designing and implementing systems, as it dictates the level of precision and reliability needed in the underlying software and hardware components. Okay, so now typically concurrent real-time systems and our solutions, we were targeting at the hard real-time spectrum. Okay, so typically our solutions will help customers in this zone. However, we see that Sim Workbench on Windows, with Sim Workbench on Windows, we can position towards the left side for model simulation and user interface testing, and where real time is not as critical. We need to do our modeling and simulation and testing, but real time is not that critical. And that's where we position Sim Workbench on Windows. Here are the real-time building blocks, and these are the CCRT portfolio of products. On the left side, you see I've drawn a orange outline where we have the iHawk and RedHawk Linux, which provide the hard real-time capabilities to run your models in real time. And to add on to that, we have the SimWorkbench framework, which is the higher level simulation framework, ideal for use in model-based design process, but again, with all hard real-time performance in mind. Now, for the model-based design V-cycle, if you look at what the model-based design the principle of testing early, testing often is essential for ensuring the reliability and effectiveness of the developed models. So this approach emphasizes the importance of continuously testing the models at various stages of development, starting from the initial conceptualization phase all the way to final implementation and verification and validation. By testing early in the development process, potential issues and errors can be identified and addressed sooner, reducing the likelihood of costly rework later on. Additionally, frequent testing allows for iterative refinement of the models, leading to improved accuracy and performance over time. So you keep on iterating and testing until you are gaining confidence in the models and their behavior, providing valuable insights into if the model is suitable for the intended application. This iterative process also facilitates collaboration between different teams involved in the development process, ensuring that any inconsistencies are identified and resolved in a timely manner. And SimWorkbench framework positions itself very well into the Model V design cycle. So from RCP to SIL to processor in the loop to hardware in the loop testing and integration and test, we can see and use SimWorkbench in all of these subcycles. So what is simulation workbench? Now we have some in the audience that have seen SimWorkbench before, have used SimWorkbench before. But for those who don't know and have not used SimWorkbench is concurrence framework. It's a real-time simulation framework which enables us to run C, C++, Simulink, FMU, and other models from different partners and different third-party vendors. We can run all these models in real time. The core concept behind SimWorkbench is a shared memory structure called as the RTDB, or what we call as the real-time database. And that is the one that enables you to exchange data and information between all the models and different tools that are integrated with SimWorkbench. SimWorkbench utilizes real-time constructs from RedHawk Linux and the Nightstar tools and runs natively. Till now, it's running natively on the iHawk systems, right? Which provide real-time capabilities. So we provide real-time modeling and simulation environment and a framework on the iHawk platforms. And our iHawk platforms are typically certified and guaranteed to provide the high levels of determinisms that our customers require. Okay, so low latency, high level of determinism on the iHawk, RedHawk Linux platform, and all enabling you to run models with C, C++, Simulink, FMU, and third-party models, allowing you to run that in real time. And that's the framework that Simulation Workbench provides. Typical applications of real-time systems and where concurrent real-time systems are used, including iHawks, RedHawk Linux, and Workbench, are shown on the screen here. So I've put pictures in some of the descriptions are obvious, but closed loop testing of primary flight control systems to provide guidance and navigation and control functions to the launch vehicles. Qualification of flight software, in-ground control system for launching rockets, satellite launch test benches, pre-flight launch tests, hardware in the loop test benches for tank self-defense systems, shift defense systems, driving simulators and flight simulators, and robot control systems and medical robots, among others. So these are the typical applications where you'll see concurrent real time and its products being used. And to encompass all this, I'll put this into X in the loop simulation framework, where X can be software in the loop, driver in the loop, pilot in the loop, or hardware, or even AI in the loop. So I'm going to give you an example. I'm going to use this example of designing a turbine engine and the FADEC controller as an example for describing what we want to do. So typically everything starts as software, and all these components are broken into subsystem design and test. So you will design individual subsystems, bring those subsystems together, and then test it to create a high-level design and test, and then integrate that high-level design and test into a big setup, which is the hardware in the loop setup, where you have the simulated plant talking to the simulated controller. And then when you're happy with your modeling and simulation, then you connect the physical plant to the to the simulated controller. And when you are happy and you have gained confidence with your model, you can say, okay, I'm completely satisfied with my digital twin. And now I can take the chance of connecting the physical jet engine or the turbine engine to the physical FADEC. So when the first time you run that test, you need a higher confidence that nothing is going to go wrong because you've invested millions of dollars into creating some of these hardware prototypes. And that is where our technology is used. You see subsystem design and test, high-level design and test, and then the big rigs used for integration and test. Now, taking the XIL example, which we see our customers using hard real-time capable systems across the entire flow. So now customers are using smaller concurrent boxes for designing subsystems. Then they need higher level of compute power, a large number of cores and RAM, because you get all these subsystems and these models and integrate into larger simulation models. And then even to a larger scale, when you have a lots of IO connected to these models, connected to test the actual hardware in the loop. However, what we are seeing is with the increased adoption of model-based design process with geographically distributed development teams, and they are using a lot of different modeling environments. Our customers were looking for a price conscious and scalable model for subsystem design and testing. And that gave us traction in developing simulation workbench for Windows. So what we see simulation workbench for Windows, and we position itself into this section where we see customers and developers using it for subsystem design and test. Also, the timing was right with Microsoft's launch of Windows subsystem for Linux with a full Linux kernel, which helped us bring this to market. So now, take this example. We have two examples. One is, a device under test, aerospace, a driving simulator, automotive. These are two hardware in the loop systems. And typically, the cost of production hardware, the limited availability of these production hardware systems, and the need of sharing resources and the risk of damage to these production systems, right, is a major concern for making these systems available for different teams and different development teams for subsystem design and test, right? So if you have, 5 groups of developers wanting to access the same resource without having higher confidence in their model, if that is going to break something in the setup, it's going to be very challenging. And in the same spirit of fostering testing early and testing often to foster a reliable, efficient, and successful model-based design process. We need to provide developers access to modeling and testing capabilities, and it should be scalable. And that is where Simulation Workbench for Windows comes. So this is super exciting because this helps us create a new add-on solution to our portfolio of products. So Sim Workbench on Windows leverages Red Hawk Linux NRT subsystem for Linux, which enables us to install Red Hawk, which install Sim Workbench in a virtual machine on Windows. With this capability, we can also support USB and network I/O devices. And we also fully support MATLAB and Simulink interface, the Python and C# API, among other features. Now, for detailed description into what Simulation Workbench can do for you, please see the video link below. And that's running Simulation Workbench on a hard real-time environment. Okay, but in this case, we are running Simulation Workbench under a virtual machine on Windows. So this is typically geared for a non-real-time environment. And with this capability, what we can do is we can see that now development teams and developers can perform subsystem level simulation and test with Simulation Workbench on Windows. And once they have confidence in their models, then they can integrate it into the production real-time system. And this leads to faster and parallel development cycles and also reduced infrastructure costs, as most of their engineers already have Windows-based IT systems. And in this example, I've shown 5 developers using their Windows systems to build and test subsystems before moving on to the big rig and performing integration and test. Now, a little bit about the Simulation Workbench on Windows architecture. You can see that we are leveraging WSL2, which is the Windows subsystem for Linux version 2. Version 2, WSL2 is much better than WSL1. So we had to wait for Windows subsystem for Linux to be clean enough for us to now take Red Hawk Linux NRT and install it as a virtual machine in here. So in this virtual machine comes with a full Linux kernel, and we have a lightweight Red Hawk Linux NRT distribution, which has packages which enable us to install Sim Workbench into this environment. On the right side, you can see this WSL2 ecosystem also supports remote desktop clients. And so we can display graphical application directly from the Linux virtual machine into the Windows environment. So WSL2 is a much better solution than WSL1, and I only see it becoming better as Microsoft puts more resources and develops it further. Now, going into some of the technical slides here, I have few slides which go through screenshots, but mostly some of them are videos. I can do a live demo also if needed. But for time, let's go through the video. So the first step is to install WSL. So if you have a Windows system, you right click on the command prompt and run it as an administrator. And once you have the command prompt, very easy. All you have to do is go type WSL space -- install, and that will install the WSL2 environment for you. Once that is done, you go and type WSL -- update, so you get the updated kernel patches. And once all of that is done, if you do a WSL -- list, it will say, okay, WSL is already installed and you have a default Ubuntu kernel. So by default, it will go to an Ubuntu kernel, which is fine. We'll use that. And that's installing the Ubuntu virtual machine under WSL for you. So once WSL2 is installed, The next step for us is to download Red Hawk Linux NRT, the MSI bundle from the CCRT website. If you have access to license.simwb.com or other portions of the website, you can get access to the MSI bundle. And from there, the MSI bundle has three pieces to it: a certificate, the actual installer, and the README. It's a very nice README written by the developer, so you can follow the instructions on the process. But I've also put screenshots in here. So once you look at the README, the first step is to install the certificate. So Windows will be able to install a Red Hawk Linux NRT. Import the certificate and place it in a certificate store and click on finish. And that's all you have to do for the first part of this. Once the certificate is installed, what you need to do is go launch the distro, which is Red Hawk Linux NRT, and it will say install Red Hawk Linux NRT 9.2. And once you install that, on your Windows, you will see that Red Hawk Linux NRT 9.2 WSL is available as an application for you. Okay. And when you click on that application, what it does, it opens the terminal. So this is a terminal on my Windows box, which is open, and it says Red Hawk Linux NRT. Okay, so that's all I need to do for installing. So step one, install WSL. Step two, install Red Hawk Linux NRT until you get to this terminal. Now, the third step is to install Sim Workbench under Red Hawk Linux NRT. The first step is going to be optional for us. Remember, this is a virtual machine environment that Microsoft has created for us. So we want to make sure it is up to date and it has all the packages. So what I'm doing here is typing some commands to get some X11 apps so I can test to see if the GUI works and everything works. So I need the sudo password for it. I'm going to type it. It will install some packages. And again, this is to highlight that this is a Linux environment, so you can install a lot of different things. So in this case, I'm testing the Xeyes application that ships with Linux. So you see that I have launched Xeyes from Linux terminal, but it opens up a window which is a part of my Windows GUI application. Okay, that's the cool thing about this integration with WSL2. So GUI applications can be directly installed. Next, I'm going to install the Sim Workbench ISO. So I created a directory in my temp folder. And the beauty about WSL is you can mount any of the Windows folder directly onto the Linux virtual machine. Okay. Also, the Linux virtual machine folders are also available in your Windows Explorer. So if you go to Windows Explorer, you can see them available and you can copy files directly. So there is like a seamless file exchange between Windows and Linux. So in this case, I've downloaded Sim Workbench ISO from license.simwb.com and put it in my downloads folder. And so I'm going to mount it, the ISO directly from my downloads folder. Okay. Of course, I forgot to put sudo. I need sudo permissions to mount it. And the ISO is mounted. So if I look into the ISO, I can see all my files present. Now all I have to do is sudo./install simwb. And this is the normal simwb installer. This is what you will use to install under any Linux environment. And so everything should be the same for you. So my GUI opens up I have two monitors. So the GUI opened up in the second monitor. I dragged it. And so you see that with this example, you see the installer being launched natively, the GUI being launched natively, and I can click next and finish the installation process. Very simple, right? Install WSL, install Red Hawk Linux NRT, and install Sim Workbench natively on the server process. Now, the step 4 is to launch the Sim Workbench Control Center. Okay, so again, going back to the terminal, once you install Sim Workbench, you can see it under user local CCR sim, and I can launch the Sim Workbench Control Center GUI directly from the terminal. And because I'm launching it from Linux, it's a local host. Okay, and the GUI is launched. So The GUI here is natively run from the Linux side. But if you remember, Windows SimWorkbench is a client server architecture. So I can, if I know the IP address of where I installed my SimWorkbench server, I can use the Windows client, the control center, put the IP address. Remember to use the host.access file to allow the IP to connect to the server. So now I'm going to use the control center running under Windows to connect to my Sim Workbench server running under WSL. And so you see the native application come up from the Windows side. Okay, so this was launch Sim Workbench Control Center from Windows, but connect to the WSL server. And this is how, uh, the server is going to look like. So the control center is going to look uh, exactly like the control center looks under Windows or Linux. And what I'm going to show you is, if you look at the very bottom left, you will see the IP address of my host. And I'm going to run our standard autotrans demo model. So you see, I'm going to run the test here, session 0, but it is running the test, running the model on the Linux, Red Hawk Linux NRT WSL2 virtual machine. Okay, so I'm going to launch the GUI and play with the GUI. Very easy, right? So all the tests that are existing under Simulation Workbench, most of it you can run in this environment. Some of the tests, if they're compute intensive, may not run because, again, we don't have enough resources on this Windows side to run everything, right? Some of the capabilities do exist, like moving a thread across processes. But since this is not a full-fledged Red Hawk Linux kernel, you don't have features like CPU shielding. The next portion of my demo, I'm actually going to take a Simulink model and use the ML toolkit to create the RTDP and generate code for my model. So this is a demo. But again, with the ML toolkit, because I'm running it on Windows, I need to know the IP address of the Red Hawk Linux server, right? So I get the IP address from my WSL Red Hawk Linux NRT terminal and put that IP address here. And then once I have the IP address, I click connect. And this will connect my Windows ML Toolkit environment directly to my Red Hawk Linux NRT environment. I'm going to create an RTDB, my new RTDB, which is the real-time database that helps us explore all the variables from the Simulink environment under Sim Workbench. So we have created and uploaded the RTDB into the server. So if I look at the control center, and if I look at the control center and the RTDB, I should be able to see the RTDB present. Okay, just hold on. Okay, so I'm waiting for the RTDB to be created here. And if I go to the control center, I can see under Simulink, because Simulink was the name of my project, I can create my RTDB, which was my new RTDB. And I load the RTDB and make sure that I have all my RTDB variables present in here so I can interact with it. And I will unload the RTDB. Once the RTDB is created, very simple. What do we need to do? We just need to create and generate the code from your Simulink model and export it. And we'll look at the MATLAB terminal and you'll see the code generation process taking place. And at the end of the code generation process, it is going to create a zip file of all the source code and ship it from the Windows side to our Red Hawk Linux NRT virtual machine, where it is going to make the executable for us. So then we can run a Sim Workbench test. So once the executable is uploaded, I'm going to go create a new test for this. for this new model. So I'm going to create a new test and use the name webinar underscore test. What was the name of my RTDB? It was my new RTDB. So I'm going to select my new RTDB, right click, and I'm going to add the Autotrans demo model to the test. And that's it. Run my test. And you can see now my test is running under Red Hawk Linux NRT. I have all my variables available. I can play with, I can simulate different sensor inputs, and look at my actuator outputs. So I'm going to add engine RPM to the chart and see how engine RPM reacts to my change in the throttle. So I'm going to set the throttle to 50%, and you can see how engine RPM reacts to my throttle. So this is a full flow, right? We have seen that we can use ML Toolkit from the MATLAB Simulink side on natively running on Windows and export everything to run under Red Hawk Linux NRT in the Windows subsystem for Linux environment. Now, because this is running on Windows and the target here is non-real-time mode of execution, we can put Simulink Workbench session to run in simulation mode. I don't know if a lot of people are aware, but if you go down to the scheduler, you can drop it down to simulation mode. So what happens in simulation mode is the scheduler waits only for the last model and the output task to finish running and will immediately start the new frame. So if you see, I've already run 3, 4, 5 minutes of simulation within a couple of within 10, 15 seconds, right? So you can see models can run faster as we test our subsystem physics. Again, time criticality is not that important, right? Because we are in simulation mode. And we are doing non-real-time simulation on Windows. So all I have to do is see if my model behaves properly for the simulated input that I'm giving to the model. So to summarize, oh, we missed one section. So what do we do with the simulation that we have created on the Windows environment? I have the big rig, which is sitting in a lab somewhere, and I need to archive all the work that I have done on my Windows system. And you can use the Sim Workbench archive tool like we have showing it in the screen here. Put a description, created archive on February 20th. And what it will create a zip or a tar.gz. And now you can take this file and extract it in any Sim Workbench environment, pass it to your colleagues, pass it to your other developers who have the Sim Workbench environment, or take it to the big hardware in the loop system lab and import it there. And all of this information will be available. So now your RTDB is available, your models are available, your test is available, and you can run it very fast, right? Very quickly, you can move it into the production environment. And those are the advantages that we see with Sim Workbench with Windows and Sim Workbench running in the non-real-time environment. To summarize, what we have presented here is a unified development environment for Windows and Red Hawk Linux, where we can run Red Hawk Linux NRT as a Windows subsystem for Linux. And you can seamlessly exchange data between Windows and Linux. I can see applications where people run simulations, store their data, and then import that data into MATLAB, directly and analyze it. This helps with faster parallel development cycles. You can have multiple developers working on different subsystems. And we can also do faster onboarding as new engineers come on board. Also, the biggest added benefit is reduced infrastructure overhead, because now you can use developer machines, which are typically IT-based Windows systems, to start prepping them for your real-time environment. Again, Our motto is test early, test often, so you get higher confidence in your models as it moves along the design process of the model-based design V. I think that is it. So let me start with any questions. If you have any questions, let me know. More information you can find on our website. The link and the QR code is provided there.
So we have some frequently asked questions about this. The first one is, can we do the same with full Red Hawk Linux virtual machines?
That's a good question. So till now, Workbench was only supported natively on Red Hawk Linux because we were targeting only real-time systems. But with WSL2 or Windows Subsystem for Linux, and it opens up a whole new world. So we are exploring, and we see a possibility where you can have, Red Hawk Linux, the full Red Hawk Linux kernel in a virtual machine, which can be installed, and then you can run simulation Workbench under that environment. It is coming soon. So.
Another one is, I see the I/O is limited to USB and network I/O. Is there a plan to support PCIe hardware devices?
So for now, we don't have the capability of having PCIe devices under Windows and have Windows driver pass on to Linux. But we are looking at possibilities of, we definitely have USB and network. So you can do, we should be able to do EtherCAT and some other network-based I/O devices. That can be integrated into some Workbench. So we see that possibility happening. But for now, there is no PCIe natively from Windows support.
And can I run multiple virtual machines under Windows?
Okay, that's a very good question. Yes, you can run virtual machines, multiple WSL instances under Windows. Workbench is typically licensed for one instance. So you may require multiple licensed versions of Workbench to run on one big server.
Okay. And what is the cost? Is another one.
So we have decided that this we want to be scalable for our customers. So we are price conscious on this. Please talk to your sales rep to see and look at the different licensing models that we have. These are annual licensing models, and talk to your sales rep, and they'll be able to provide you a code for this one.
And can I use FMU models like you did Simulink models?
Yes, so we can definitely use FMU just like we used, and I showed you a flow of using Simulink models. You can definitely use FMU models, import them into the Workbench environment and run it.
All right, looks like we don't have any other questions.
Okay. Any last questions? If you need more information, visit our website. We'll make this webinar available on our website and our YouTube channel. Please talk to us if you need more information. If you'd like to get a demo, request a loan for us. Can we use, I see one last question comment. Can we use AMSIM models like Simulink models? That's a good question. We have not tested it. I believe you should be able to run AMSIM models like Simulink models. But Ahmed, we will take this offline and get back to you once we test it. Me being an engineer, unless I test it, I have 95% plus confidence. I'll not say yes to it, right? Quite possible, but we will get back to you once we run it. Okay, I guess that is it. Thank you all. Please follow up and let us know if you have any further questions. And bye-bye now.